Hi, thanks everyone. I would like to thank the in-person audience in Palm Springs and also our digital audience for attending ArcGIS Maps SDK for JavaScript capabilities and techniques. I'm Jose Bañuelos and I'm joined by my colleague Ann Fitz and also Jan answering questions. We're product engineers for the ArcGIS Maps SDK. And so for today, we're going to go through how we can bring in different types of data, starting from web maps, web scenes, to different types of data ranging from feature layers to CSV layers or into imagery. So some of our new layers that we're also introducing. We're then going to go and configure the symbology, improve the visualizations of our maps with the data-driven styling section. We're going to get into some basics and intro with the map components and other web components that you can utilize in your applications for more map interactions. I'll then provide a small preview of the editing capabilities on the web, as well as some of our recent enhancements. And finally, we're going to show off the strength and power of the client-side analysis in the SDK. So first, the easiest way can bring in your data is through a web map or web scene, a pre-configured web map or web scene from the map viewer in either ArcGIS Online, Enterprise, or the ArcGIS location platform. And when I mean easy, that means for us, working with the Maps SDK and the map components, it's as easy as just a single line of code, in this case, HTML. So with the map components, we can bring in the ArcGIS map component and plug in our web map ID configured in online. If we want to bring in a web scene, it's the exact same steps. Instead of the ArcGIS map component, we're using the scene component and plugging in item ID to our web scene. So the emphasis on the very low code, which has been a theme throughout this week. When working with enterprise data, there's an extra step, and that's providing your portal URL. So by default, the item ID from the map component points to ArcGIS Online items. So if you're working with the enterprise portal, we need to specify the portal URL through the Esri config. So we just need to import that config module and pass in the URL to your portal. So the fully qualified domain name followed by the portal web adapter name. If working with the ArcGIS location platform, you're also utilizing the Esri config. But in this case, you're using the API key that you generate from your account. So let's take a quick demo at getting started with just bringing in a web map to your with your application. So here we see a pre-configured web map through the map viewer showing industry predominance by county in 2016 data. So as we can see, we have a lot of visualizations going on that has been pre-configured either by maybe someone else in your organization. And the way we bring that in through the Maps SDK and map components is, here's an example with just HTML file. So the code we're going to show is HTML and vanilla JavaScript, just to have like the core equal similarities in how we showed our code, because the map components are easy to bring in with several different frameworks. And so we wanted to focus on just vanilla JavaScript that can be utilized by anyone using different types of frameworks. So first, for this example, when we bring in the SDK through the CDN, first we're loading the calcite components, then the JavaScript SDK, then the map components. And the code to bring in our web map that we saw earlier is just by plugging in the item ID as mentioned. So in this example, I'm also adding the zoom and legend components just to give it some more interactivity in our application. But let's say we wanted to bring in a web scene instead. It's as easy as just bringing in the arc scene component, comment that, save this, go to our app, refresh. So the item ID is pointing to this web scene. It's pre-configured through the scene viewer, so it's as easy, and we can now interact with our web scene or application. So if you're working with the enterprise example, so as mentioned, we need to specify our portal URL and then pass in the item ID pointing to that web map. So we have an example of a web map. So we're showing a water distribution utility network, and we pre-configured all the symbology, and this also has some display filters as well, showing how you can bring in your enterprise web maps as well. So now let's see how we can bring in individual different data types. So the SDK supports over 40 different data types, ranging from the new knowledge graph and the link charts to WFS, WMS, oriented imagery, and several more. And each data type has its corresponding layer associated with it that allows you to bring in that data into your maps and provide capabilities like configuring your pop-ups, configuring your symbology, preparing it for editing as well by configuring a form template. So the layer allows us to easily use the SDK to interact with your data set. So in the previous example, I showed an example of bringing in data through the web map, but let's say you wanted to start with a blank map, and the way we wanted to bring in a brand new feature layer that was not already in that web map is by first bringing in the corresponding layer to your data type. So in this case, since we're working with the feature service, we're going to use the feature layer class. So I import the feature layer module, specify the feature service URL, and add it to our map. If we're working with a layer item that was pre-configured through the map viewer, we can also initialize the feature layer, but instead of passing in the URL to the service, we can use the portal item property to specify the ID of the layer item that you can find in the item details page. So let's take a look at some examples. I'll first show the data. So here we're loading a feature layer through its feature service URL. So what we're seeing for the global power plants layer is the default symbology that was authored when this layer was published. If we go back and take a look at the code, this is the exact same code I showed earlier for bringing in your web map or web scene. Only difference is, since we're not starting with the web map or web scene, we're needing to specify first the base map we want to use, center and zoom to set our extent, and then we're using the same components. Just like I showed, we want to load our feature layer. We first make sure that the map component is loaded, and then we can initialize our feature layer and add it to our map. When working with a portal item instead, it's the exact same steps. Only difference is we replace the service URL with the portal item ID property. So if we take a look at the same data that was now pre-configured through the map viewer, but we're loading it through the portal item instead, we see that we can take advantage of clustering and other symbology improvements to get a bit better story of our data, all stored within that portal item. So now there's going to be a few more sessions on working with different data types. So if there's a specific interest on working with like 3D data, maybe 2D data, there's going to be some other sessions this week that would be great if you wanted to learn more about bringing in other types of data into your applications. So now I'll pass it to Anne for data-driven styling.
All right, thanks, Jose. Now we're going to talk about data-driven styling. And the really basic part of that is understanding renderers. So renderers determine how your data is visualized and rendered in the map. It can be tied to a specific field or multiple fields. And different renderers can be used depending on your use case. For instance, you could use a heat map renderer to visualize the density of features. Or you can use a dot density renderer to visualize demographic census results, or a unique value renderer to visualize the different types of data that exist in your data set. Then we also have visual variables, which allow you to create more of a multivariate visualization. And this allows you to tie your visualization to a property or a field in the layer itself. And those field values can determine either the color, size, opacity, or rotation of the features. It can also be based off of an arcade expression as well. For example, this rotation one is using both a color and a rotation visual variable. The color is representing the temperature at that location, and then the rotation is representing the direction of the wind speed. All right, and the next thing is layer blending. So this allows you to kind of combine layers to create a seemingly new layer or an effect of an appearance of a new layer. The results are kind of Photoshop-like effects on real maps. So this example here shows combination of a feature layer and imagery layer here, where the imagery layer is displaying land cover classification rasters, and the feature layer contains county crops data. And the image on the right shows the result of layer blending, which is using a destination in blend mode to take that feature data and overlay it on top of that imagery layer. And then we have layer effects. So this is another feature in the SDK that provides visualization enhancements to better illustrate specific data sets and improve the cartographic quality of your maps. Again, this applies kind of like a CSS-like function to create visual effects. They can be feature specific. So as you see, as in this example, where the user is dragging a slider, the effect is only getting applied to specific features in that slider, or the effects can be applied to all features in the layer, as we see up here with the bloom effect applied to the global fault lines and earthquakes, or a drop shadow being used to help emphasize a given country, like Australia in this example. Okay, now I'm going to jump into a demo on data visualization. So let me switch over to my demo. Oh, sorry. Make sure that we get, there we go. Oh. Technical difficulties. Okay, great. So when I go to visualize my data, I always start in the map viewer. There are so many different ways to visualize your data, but in order to visualize it properly, you need to first have a good understanding of your data. And the map viewer really helps me do that. So let's test out a bunch of different ways to visualize our data. Right now, we're looking at global power plants or power plants around the world. And right now, just using that location style, which is giving us just a point on the map, showing us where those power plants are located. But we can go ahead and switch to a heat map renderer. And now we can see more information, like the density of where these features are located. So we get, well, we'll have more power plants up in the UK area and maybe less over here in Eastern Europe. Then you can also create data-driven visualizations and add let me actually switch back to that location style. And now I'll add a field. For instance, let's check out the capacity of these power plants. And the map viewer will automatically provide some styles for you based on the smart mapping APIs that are provided by the JavaScript SDK. And these help you to understand the nature of the data, like the statistics and the spread, and will also suggest color ramps based off of the base map that you're currently using. So we can see that it provided us with this counts and amounts style. We can test out some of the other style. We're using color. This is using that color visual variable. The previous one was using that size visual variable that we talked about earlier. Or you can do both, color and size. Now, this visualization isn't great. Again, smart mapping is just trying to take its best understanding of the data and use that to visualize the layer. But if we scroll over, we can see that there is this huge power plant over in China that is really skewing the data over here in Europe. So you can go in and kind of adjust. So the smart mapping just provides some defaults, but maybe you need to pull that down in order to get a more interesting visualization in the area of interest in your map. You can also go in and change anything about the symbol itself, the symbol that's being used, the colors, et cetera, et cetera. Let me switch to a different field to show the primary field type. So this is going to use a unique value renderer to show the different field types that exist in our power plants layer. In the map viewer and in the API, you can also enable aggregation to kind of get a better understanding of your data in this way. So clustering will take into account the renderer that's already used on your data. And so in this case, you can see we still have that power plant visualized by the fuel type, but now it's getting clustered, and the clusters are using the predominant fuel type to represent the color of the cluster. We also have charts, which are really nice for when you're rendering, clustering predominant data, because it gives you a quick overview of what features reside in your given cluster. Now, clustering occurs in screen space, but we also have binning, which occurs in map space. And all of these provide options so you can really dive in, fine tune, and adjust those visualizations to make it what you want. I'm going to go ahead and turn off aggregation for now, and we can add a multivariate visualization. So let's, in addition to visualizing the power plant type, we can add another field like capacity. And again, the smart mapping will provide us new styles based on the fields that we provide. So now we get types and size, visualizing both the capacity and the size. For the sake of time, I've already styled this a little bit differently just to get some of the colors to match, solar's yellow and hydro's blue and waste is brown, and kind of adjusted some of the sizing there to get the visualization that I want. The other thing you can do in Map Viewer is set effects on the layer. So I mentioned this a little bit in the slides, but you can either apply the layer effects to the entire layer. Say you want to just do a light drop shadow to make those features really kind of jump out of the map. Or you can also apply feature-specific effects. So here, maybe I want to focus in on a specific field type in my map. So maybe I want to highlight only the features, the power plants where the field type is hydro, and then I can decide how I want that effect to be applied, just using some of the nice default options in Map Viewer. The great thing about everything that I just showed is all of this gets saved directly to the web map or directly to your layer. So it takes all of the coding out of this visualization process. Again, you can still do all of this in code, but I think that using the Map Viewer UI really simplifies the process, makes it easier to understand and explore your data, and then bring that into your application later. Now, many of the things that I just showed were powered by the smart mapping APIs in the SDK. So if you are building kind of a map authoring application, or maybe you want to explore your data outside of the map viewer, I recommend taking advantage of these smart mapping APIs. As I mentioned, they really take into account the data in your layer and also the map that your layer is being displayed on. So you'll notice if I change this base map to a dark base map, automatically that renderer will update to a color ramp that really works better with that kind of base map. So definitely recommend checking out smart mapping. And also wanted to recommend, there's this styles and data visualization guide in the SDK site. And it really walks through all of the different styles and renderers that we support in the SDK. And it also talks through some best practices when visualizing your data, especially when working with large data sets. A lot of time and effort was spent on these guide pages, and so they're a really great resource when visualizing your data. Okay, let's switch back to my slides. So that's just a little bit on data visualization. There's so much more that we could show, and luckily others will do that for us. So if you're looking for more on data visualization, you can see a demo theater later on creating your custom visualization style, demo theater tomorrow by Jan on visualizing change over time, and then another tech session on real-time and historical data visualization. So definitely recommend checking those out. All right, back to you, Jose.
Thanks, Ann. So at the beginning of the presentation, we showed working with the map component to bring in your web maps, web scenes. And so far, I've not showed any JavaScript. The only JavaScript we used was if you're working with the enterprise example, specify the portal URL. So in addition to the map component zoom and that we also saw and the legend, there's additional components that we have that'll allow you to bring in several different capabilities encapsulated within these components. So here we have an example of our shadow cast and our base map gallery added to the scene component. So as we showed earlier, we can specify the item ID of the web scene, and then the purpose of the shadow cast is to provide an analysis over these buildings of the shadow at different times of the day. So in combination with the base map gallery to switch the base maps underneath. So this functionality, this entire application that we are seeing this is the HTML that was needed to make this. As I mentioned earlier, we also have to import the CDNs to calcite the Maps SDK and the map components. But this is just the code that was needed to build this application. In comparison, if you're just working with the JavaScript SDK using the widgets instead, this was our previous workflow, and it did require more JavaScript, but working with the map components condenses that down a lot more. So with the map components we've shown, I'm going to show a few more for editing. So all of that functionality is out of the box and easy with that one line of code of bringing it in. There's additional properties you can configure, and you can even set up events a lot easier. So that's what makes it more friendly with different frameworks. We also offer different web components, like the chart components. So we're bringing in different layers and different data types and visualizing it through a chart. We also show coding components. We also have coding components to provide like text editors. In this case, we just have the arcade editor, which allows you to author your arcade expressions easily. And we also have the newer embedded map component, which shown in plenary by Omar today. So you can bring in an entire web map with some pre-configured components as well directly into your site. So let's take a look at some of the doc and examples of the map components. So if we start off with the JavaScript SDK site, if we go to the references, and then we go to the map components, we have a list of all the different components that are available to us, and it also shows us how to work with them. So here I have the bookmarks component, for example. And the cool thing about this site is that we can play around with the properties available and see the update immediately. So for example, we have the base map, the bookmarks component, sorry, and I don't see a filter on it. So I'm gonna show the show filter, which is set to false by default. I'll set it to true. So now we have a filter show up. And then if I set the placeholder, let's say search by national park, we can see how responsive these components are as we see the demo being updated immediately. Not only that, if we look at the code tab, we see the updated properties that we just modified show up here. So we can just literally copy this code and paste it into our applications that are already prepared to bring in our map components. So very minimal code to achieve this, and you can even do this, configure it directly through the site. So for more detailed workflows working with the map components, and maybe you're more interested in using them through frameworks, there's some sessions this week. So if you want to attend to learn how to bring them into different frameworks, or even a deeper dive into when you can bring those components and how to use them in your applications. So now to give a preview of what we support for editing your data. So we showed how to bring in your data, how to visualize it, how to view it, but sometimes you also want your users to be able to edit that data. So we have two main components that we provide that encapsulate a lot of web editing capabilities, and that's the feature table and the editor components. So for the feature table, it provides a tabular view of your data that you can just view or edit. And so that supports basic adding, like updating and deleting of your records. New within the last couple releases was support for attachments and related records, as well as highlighting. So I'll show examples of all this. We can also configure a table template, so you can configure which columns you want to show. And then with the recent capability of exporting to CSV. So for point data, we export the geometry and the attributes, but for polygon and polyline, we just export the attributes for the export to CSV from the feature table. So let's take a look at a couple demos using the feature table component. So here in this data set, I'm just going to go through some of the capabilities. So if we start to hover over some of these rows, so we will see this temporary highlight that is new to the SDK. If we select view records, and I'm going to just show our selection. So we now can see multiple highlights. So the cyan shows the feature set that's selected, and as we hover over each record, we can see the secondary highlight in the yellow. With the export to CSV, to get to that point, first you have to have a selection, and now we could export these features. Since they're polygons, we're just going to export the attributes. So I'm going to show all. This data set also has related records, so I can navigate through the relationships by going through the columns. So this northeast feature has 12 related records, and these themselves have related records as well. So we provide an easy way to navigate through nested related records workflows as well. So in this example, it's the viewing part. And before we get into the editing, I just wanted to show the code for how we bring in the feature table. So we did have to add just a little bit more CSS to get the table to fit nicely, but pretty much we're just wrapping the feature table inside our calcite shell, and then we have our map as well. So in order to make sure that the feature table is referencing the data in our map, we need to set the reference element to the map component. So in this case, I enabled the related records property so we can view the related records as well. So normally, there's two ways in which you can set up your data to display in your feature table. Probably the easiest way, and you can do it through the HTML, is there's a property for the data URL. So you can specify the service URL to your data, and then the table will display it. In this case, I'm having to wait for the map component to load before I grab a layer from our web map and in order to set it as the layer prop in the feature table. The reason I need to do this is so we can take advantage of the highlighting on the map. So there's a couple of ways to do it, but this was the code needed to configure the feature table. And now for the editing example, we have the ability to update existing records. So I can update this 1 to 9. We also have that selection capabilities and also like the export to CSV. But what I wanted to show is, let me show all. Since the feature table supports domains, and now with the last couple of releases, we had support for subtypes, it's closer to some of that behavior you might be used to when working with Pro. So this data set that we're showing has information with subtypes. So the functionality that's unique when working with subtype data is whenever you switch the subtype field, you are prompted. So in this case, the region subtype field, I'm going to switch California to the Midwest. Makes no sense, but the purpose is to show the capability. So we get prompted whether we want to keep our current edits or go back and default to the values that are authored with the subtypes when you publish your data. So I'm going to keep this to use the default values. And what that does, it refreshes this row and it populates any field that has default value set at the subtype level to the ones that it was defined. So in this case was the region population was now updated to 68,000 instead of the normal 78,000 for the West subtype. The way and the code for that is the exact same. Nothing changed. The only difference is I'm plugging in a different web map ID to our map component. And finally, the second component that really encapsulates a lot of editing capabilities is the editor component. So I'm only showing a preview, and I'm really going to hold back on showing the editing capabilities because there's too many to show. So we have a session coming up which we'll show where we go all in on editing. So with editor, you have the ability to display your feature templates that you author, like from Pro, or if you're creating your layer from online or our portal, you have access to your feature templates. And this release with support for group and preset templates, which allows you to now create multiple layers, multiple features across different layers in the same feature service. So it eliminates a lot of steps of having to manually create a feature at a time. You configure your data to have these group and preset templates. It's a lot more streamlined. We also, editor, just like feature table, supports basic editing from attachments, attribute updates. Editor does provide geometry updates as well as support for related records. Editor supports both 2D and 3D workflows. We also provide snapping, and we new as of the last couple releases, we also display a grid that you can snap to as well. Some of the advanced capabilities from editing range from editing your utility network associations to rule-based snapping, all out of the box within the component. So I'm going to show an example of the editor component. So here we have a data set. So we have a park, Brookside Park. So we have a boundary polygon we have a few lights and light coverage features. So let's start by showing some of our snapping capabilities. And I'm going to turn on the tooltips as well. So I'm going to draw a new park boundary right next to it. And with support first, I need to enable snapping first to the other layers. So the reason why we didn't see any snapping visuals first is because I need to go in and check the layers that I want to snap to. So I can enable them all at once, or I can choose which ones I only want to snap to. Right now, I'm just going to snap to all of them because it's quicker. So now I'll draw our park boundary, and I can snap to like the existing boundary. And let's say, so I'm going to draw a park over existing buildings. So this is not a real life scenario, but I'm just to show the capability. So I'm snapping to an existing boundary, and with the tooltips, I can tab and set maybe the distance I want this to be, maybe 60 meters. And then I can set that. And with the guide, with the snapping guides, I can also see the parallel lines as well as perpendicular lines for the indicators. So it's giving me a nice rectangular shape. And yeah, complete that. So new this release. Sorry about that. Let me just draw that one more time because I need to show important feature. So I'm just going to draw this really quick. So create this. And in the previous release, we added support for a new grid. So with the grid controls, we can display a two-dimensional grid. And I can use the placement tool to snap to existing features. So I have this uniform grid over our map. And now, let's say I wanted to add some park features. So I can use the grid as a guideline. So I'll use the polygon tool. I can snap to the grid. Let's say I wanted to be a little unique with the shape. And it makes it easier to pretty much achieve what you want using a grid as your guidelines. So new this release as well, probably if you saw the plenary, is this pending features. So I have not yet submitted these edits to the service, but we still have the ability to go in and either zoom to the feature, highlight it, but it'll be easier if I show another feature that I create. So for the second feature that I'm creating, I'm going to use a new tool. So new this release as well is this toolbar in editor that allows me to switch the drawing tool that's supported. So I'm going to use a freehand in this case, or should I do, I'll do freehand. And now what I wanted to show is we now have this pending features list with both features that we can hover over them and see the corresponding feature highlighted on the map. But not only that, the preview symbol shows the exact or pretty close exact thumbnail of the feature you drew on the map. So it's easier to go back and know which one you want to go back to and modify before you submit your edits. So I can zoom to each one, and I can even choose to delete them from here. But I don't know if you caught this, but with this release as well, we added support for the new supporting additional draw tools that you publish as a feature template. So when you're authoring your data from Pro or online, you have the ability to set which draw tool you want the feature template to use. So the parks is actually set up and published to have the freehand tool as the draw tool. So that's why I am able to use the freehand tool as soon as I choose that template. So this was one of our requests from our users to be able to support this. And now with a toolbar, you have the ability to switch to different draw tools. So I could keep going, but this presentation is not about editing. I'm gonna go back and show that the session that we're gonna dive deeper into web editing is later on tomorrow with myself and my colleague John, where we're going to show some of the new functionality with a little bit more custom workflows and advanced like scenarios as well. So I'll now pass it back to Anne for client-side analysis.
Awesome. Thank you, Jose. So we've talked about how you can bring in your data. We've talked about how to visualize your data, talked about how you can use components and editing to interact with your data. Like the final big feature of the SDK is doing client-side analysis. So in order to do client-side analysis, you first need to understand the concept of layers versus layer views. So we already talked about layers as data sources to our map, but layer views are what renders those features in the view. They're created when a layer is added to a map view or scene view or ArcGIS map or ArcGIS scene component, and they're responsible for rendering those features in the view. And this allows for client-side queries, analysis, filtering, statistics, and highlights for the features that are currently displayed in the view. Another important aspect of client-side analysis are the new geometry operators, which provide 2D capabilities for performing client-side geometric operations on points, multi-points, lines, polygons, and extents. The operators are officially out of beta at this version 4.32, and they provide functionality equivalent with the geometry engine, along with 23 brand new operators. They will eventually replace the geometry engine, and also the new operators support curves, which will lay the groundwork for later support of editing curves coming later this year. Yep. And now I'm going to jump into a couple of different demos for client-side query and analysis. So let me just switch over to my demos. Okay, great. Just want to make sure everyone can see that. So this map might look familiar to you. It's the same one that we created earlier in this data visualization part of this session. But now I'm bringing that web map into my application and setting some layer view or client-side layer effects. So similar to how in the map viewer, you could select a power plant type and perform a layer effect, I've created, using the calcite components, a similar little option so that users can easily filter through and view just the power plants that are of that certain power plant type. So how am I doing this? Let's take a look at the code. All right, so here I am using some calcite components to create a nice UI for my application. And inside my shell panel here, I'm using a chip group to create each of these different power plant types to provide that selection experience. And then all I'm doing to get that entire map and all of that data visualization of the layer is just bringing in the item ID of the web map in my ArcGIS map component. I'm also adding a legend to the bottom right-hand side. And then the code to update this map and update the layer effects is quite simple. So I'm defining a global variable for my layer view, getting the map component from my application, listening for the view ready change, which tells me that the map is ready to be interacted with. And then I'm just going to find the global power plants layer from my map so that I have access to it and I can make updates to it. Then I'll use the when layer view function on my ArcGIS map component for this power plant layer to get the layer view so that I can perform client-side analysis. Then simple event listener for the calcite chip group select. So anytime I select a new chip, we're going to call this handle filter change function. And this is just going to get the selected item from my chip group and apply a feature effect on that layer view, passing in a filter where that primary fuel, which is the attribute in my data, is equal to the chip that is selected in my chip group. Then I'll set an included effect of a drop shadow, and for those features that are not included, I'll set an opacity. Otherwise, if nothing is selected, I'll just remove that feature effect. So this is all happening on the client side using the data that is currently, the features that are currently available in my view, and that's why we get such a nice quick response here because no additional requests are going back to the server. Next, let's take a look at a geometry operators example. So this map might look a little familiar to you. You saw it in Jose's editing data. You can even see his newly drawn park boundary here. But I did spice it up a little bit, I guess, with some visualization, just using some of the layer effects in Map Viewer and blend modes, or actually just layer effects. I took this map and made it nighttime because we're looking at light coverage in the park. So I was able to flip the base map using a layer effect, add some bloom to the light features to kind of make them shine, and add some blur for these light coverage boundaries to kind of give a shadowy, I don't know, effect. All right, but what we're looking at in this application is we're using the geometry operators to calculate the light coverage. So when I click this button, we'll get a percentage, 30.7% of this park is covered by light. All right, let's take a look at the code that makes that happen. All right. So here I have a function called get park light coverage percentage. I'm going to get the boundary feature, which is the park's boundary. And then I'm going to get the light coverage feature. So those are from my light coverage layer. And then I'm going to create a union of those light coverage features. So here I have a function called get features union, pass in those light coverage features, and this is just going to get all of the features from that, that layer and execute the union operator, that's that geometry operator, with those feature geometries. Now, in order to see what that looks like, we can uncomment this line of code to display a graphic that will show the results. Let me just refresh, and now you can see the results of that union. So all of my light coverage features are highlighted, and any intersecting or overlapping values are not going to be included. All right, the next step is, I'm going to comment that out. The next step is to find the difference between the park's boundary and that intersecting features union. So I'm going to call this function called getDifferenceGeometry, where all we're doing is using that difference geometry operator and passing in the park boundary and my union of features. Now, to show the results of that, we can display those in blue. Let me just refresh again. All right, so now we see, oh, sorry, zoom. We can see the results of that geometry operator. We can see that the areas outside the park boundary are not going to be included. It's going to get cut off there, and we're just looking at the difference between those features and my boundary. Now the last step is to get the percentage of coverage. So we have this function called getAreaPercentageLeft, where we're just doing a area operator to calculate the area for the initial geometry and the difference, and then we'll calculate that as a percentage. And that's how we get the percentage displayed up here. So this is just one use case for the geometry operators. They're all happening client side. That's why it's really fast. And there are a ton more operators to explore. So definitely recommend checking that out. Sorry. Okay, now the last thing I wanted to show, I know we haven't talked too much about 3D in this demo, or in this session, but it is a 2D and 3D API. So I wanted to show a 3D example for querying data and querying statistics. So in this application, we're looking at different buildings made out of different materials, and I can go ahead and place a point in the map to query for geometries and create a chart. So here we'll see the building year and the building materials. And as I update this geometry buffer around the feature, we're going to get the chart updating. And as I scroll or slide. And the query will update to get new statistics on these features and update the charts. Again, this is all happening client side. So if I pop open my developer tools and again, change that buffer, we don't see any new requests coming through because it's only working with the features that we currently have available to us on the view. So that's why it's super fast and performant. All right, let's take a look at the code for this one. So here we're looking at a scene. So I'm bringing in a web scene using the ArcGIS scene component, using some other components like zoom, navigation toggle, and ArcGIS placement to put my own custom content into the map. And if we look at our JavaScript here, we can see we're doing the same thing, getting the layer view from that scene layer on our scene component. And then we're going to query the statistics. So the JavaScript SDK is really, really powerful when it comes to querying. There is a lot that you can do, and I'm afraid we'll just get to scratch the surface of it today. But what we're doing here is setting some statistic definitions based on the layer. So when the building material is concrete or lightweight concrete, then we're going to create this new statistic field name, calculate the sum, and so on for all of the different building materials and for all the different years that these buildings were created. Then we just create the query on the layer view. The layer view is important client side. If you set it on the layer itself, that would be a server-side query. So we would be sending requests back to the server. We'll pass in the sketch geometry. So that's that area that we sketched. Pass in the buffer, set the out statistics. So those are the statistics definitions that we just defined right above. And then on the layer view, we'll call query features with the query we just created. And then we'll use the results of that query to update some charts. So we can do this with points. We can draw line features, and this will all be performing client side. Even if I draw new features, again, no new requests coming through in the DevTools. So that was just a quick intro to client-side analysis. There is going to be a whole session on it tomorrow. If you're interested in learning more, definitely recommend checking that out. So that's all we had time for you guys today. We can now take some questions. I know there's been some questions coming through from the audience watching virtually, but we would also love to take questions from the audience here in person. So, any questions?
No, so we had some sorry. Go ahead.
Can I then add layers to it?
Yes. So the question is, he knows that he can create a map using the item ID, but if you're doing that, can you also add additional layers to that map? The answer is yes. You can access the map property on that map component, and then update the layers just like you would normally. So whether that's adding new layers or changing the existing layers or anything, you have access to all of that. Thank you. Great question.
If I don't have a map and I don't want to grab it from the item ID, and I initialize a new map and use it in the component?
So the question is whether we can create a map and then assign it to the component, and it's completely possible. It's actually like the two patterns we promote. Either you have the item ID and then you want to assign it into the HTML element directly, or you can create a web map or a map in JavaScript and then assign the map property on the ArcGIS map, like you would do with a map view otherwise. Yeah.
Yeah, and to add to that, one of the examples we showed that's available in the GitHub, if you scan the QR code, it's when we're loading the feature layer. So we're starting off with a blank web map, so you can use that as an example as well. But we also have examples through the documentation as well, so it's totally possible.
Good question. Anyone else?
Jan, you had some online?
Yeah, so I had some questions online, great questions like how to use map components with TypeScript. So that map components can be definitely used in JavaScript or TypeScript. You can just grab, have your HTML document, have your components there, and then from your TypeScript code, you use query selector exactly like you did, like Anne did. That's one way. The other way is to use a framework. If you use React with TypeScript, you would have access to auto-completion and all these goodies, and then use directly the map components into your React app or any other frameworks also as well. We had another question about will client-side analysis work against non-hosted feature services. So client-side analysis works for all feature layers coming from either ArcGIS Online or Enterprise. But also, if you have map services, you can use the maps, each individual layer into your map service. You can use that as a URL to a feature layer. So I have also client-side analysis for that. But also, it works on other layer types like WFS, OGC API feature layer, GeoJSON, CSV. So yeah, it's available. As soon as we have features on the client, we expose the capability to have client-side analysis.
There's one.
Yeah.
Example you showed where there was the radius that grew, you could update the pie chart that pop out.
Yeah.
If that's all client-side, how does it handle it if the user zooms in where they don't see the entire area of that circle? If it's only returning what's in the view, are you not getting information?
That's a good question.
Yes, so the question is whether if the user zooms in and then the query uses a distance that is greater, that is going outside the view, what the results are we getting back? Yes, you get approximate results based on what is on the view. If you need to handle this case, then you need to go back to the service. But I would say it depends because if the layer is small enough, for example, if it's a point layer that is under 400,000 points, which is already pretty big, then we will do a snapshot of all the points, so they will all be client-side, and we won't make any more queries as user zooms in and out. And in this case, the result will be accurate. And for that, if we can open the documentation.
Okay.
So on the reference, core API, feature layer view, you will have to go
Feature layer view.
Feature layer view. Yes. There are flags, so if you scroll down, there is look for as all features. So the feature layer view gives these flags as all features and as all features in view and as full geometry. And these flags tells you basically what is available on the client. So if you have like as all features is true, it means we downloaded everything. So you can perform all your requests just on the layer view client side. If it's false, you can check as all features in view, which will be false. For example, if we had some errors during the queries, or if you have a display filters that was set demoed yesterday by Jeremy, it's like then in this case also need to go back server side. Yeah.
Great question. Any other questions in the audience? Good, I think. Is there anything else? All right, so thank you all for coming. Please share your feedback with us. Let us know if this content was relevant to you. Let us know how we did as presenters so that we can make sure we're giving you the most appropriate content. We can tailor it for next year. Connect with us on social. We have some links there. And that's all. Thank you so much for joining us today, and enjoy the rest of the week.
Thank you.
Thank you.